Physics class 11 chapter 5 laws of motion. In the last class we have studied Aristotle's fallacy, the law of inertia, Newton's first law of motion. Today we shall study momentum and impulse, Newton's second and third law of motion, and some common forces in mechanics. Let us start with momentum. Momentum of body is defined as the product of its mass m and velocity v and is denoted by vector p. So momentum is the product of the mass and the velocity. So vector p is equal to m into vector v. P is equal to mv. Momentum is a vector quantity. For a given mass, the greater the speed, the greater is the opposing force needed to stop the body in certain time. So suppose an object is moving with a high speed, then to stop that object you require greater opposing force. For example, a bullet fired by a gun can easily pierce human tissue before it stops. You know that a bullet which is small in size and small in mass, but if it is fired from a gun, it has got a high speed, then it will pierce the human tissue easily. The same bullet fired with moderate speed will not cause much damage, but if the same bullet if you are throwing with hand, then you know that it will cause no damage. A greater opposing force is needed to stop a heavy body than a light body in the same time if they are moving with same speed. So similarly, if you have got two objects, one is heavy and one is light, and they are moving with the same speed, then to stop the heavy body you require more opposing force than the lighter body. Now with this we can state the Newton's second law of motion. The statement is the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So change of momentum is proportional to the applied force. So we can say F is proportional to delta P by delta T. Okay, this is momentum and this is the applied force. If you remove the proportionality symbol, you can say F is equal to K delta P by delta T, where K is the constant of proportionality. Now if we take limit delta T tends to 0 and K value is 1. If you take delta T tends to 0, then in a calculus this will become derivative of P with respect to T and K value is taking as 1. So this can be written as F is equal to dP by delta T. For a body of fixed mass m, F is equal to d by dt. Now if you are taking mass fixed, then momentum we have defined just now, it is mv. So write v is equal to mv. Now m is a fixed, so you can take out of the differentiation. So you get m into dv by dt. But dv by dt is nothing but the acceleration. So you can write this as a. That means F is equal to m into a. So what we can say is force is proportional to the product of mass and acceleration. SI unit of force is Newton. Let us define 1 Newton. 1 Newton is the force that causes an acceleration of 1 meter per second square to a mass of 1 kg. So if you have got an object of mass 1 kg and if you are accelerating it 1 meter per second square, then the force which is given, that is equal to 1 Newton. That means 1 Newton is equal to 1 kg meter per second square. In second law, F equal to 0 implies A equal to 0 is consistent with the first law. So in this second law, if you take force F equal to 0, that means M is not 0, that means A equal to 0, and this gives you the first law of motion. Second law of motion is vector law. Okay, we can see that it is vector F is equal to m into vector A. That means this is a vector form. If it is a vector, then we can write in component form, in x component, y component, z component. So we can say fx is equal to dpx by dt. This can be said as max. Y component fy is equal to dpy by dt equal to may. And z component mz equal to dpz by dt equal to maz. What does this mean? This means that if force is not parallel to v, that is velocity, and makes some angle with it, it changes only the component of velocity along direction of force. The component of velocity perpendicular to force remains unchanged. Let us take the example of the projectile motion. Under the projectile motion, Under the vertical gravitational force, the horizontal component of velocity remains unchanged. Okay, we have done this in a projectile motion, that the object is falling, then under the gravitational force, then the horizontal component does not change. Okay, component of the velocity does not change, only the vertical component. The second law of motion is applicable to single point particle, rigid body or system of particles. So it is applicable to a single point particle, the rigid body or a system of particles. Force F is net external force. Okay, that is this force. Okay, this force is external force, net external force. Any internal forces in the system are not to be included in F. So if you are taking the system of particles, okay, then it will have internal forces, but those internal forces are not included in the net external force F, that is in this force F. Force F at a point in space at a certain instant of time is related to acceleration at that point at that instant. So force at the force is related to the acceleration at that time, okay, not after some time, okay, at that particular instant. That means acceleration here and now is determined by the force here and now. So acceleration here and now determined by the force here and now, not by any history of the motion of the particle. Okay, so it is here and now, not what is done in the history or done time away, okay, at that particular moment. Impulse, the product of force and time which is change in momentum of body is called impulse. So impulse is defined as the product of the force and time which gives change in the momentum. Okay, this is called your impulse. We can say impulse equal to force into time duration, and this gives you change in the momentum, right? So impulse equal to force in time duration into time duration equal to change in momentum. Large force acts for very short duration. So in impulse, what happens that a large force is acting for a very short time of duration. Okay, that what happens in the impulse. For example, a ball hits a wall and bounce back. You know that a ball comes with, if you are hitting it with a very high force, then it will bounce back and it will touch the wall for a friction of time, for a 1 second, for example, right? So it is a high force but for a short time duration. Impulsive force, a large force acting for a short time to produce a finite change in momentum is called an impulsive force, and the force which is here, that force you call it as an impulsive force. Now we shall state the Newton's third law of motion. To every action there is always an equal and opposite reaction. Now here action and reactions are the forces. Okay, so the same statement we can write in terms of forces as forces always occur in pairs. Force on body A by B is equal and opposite to the force on the body B by A. Okay, so the same statement we are writing in terms of forces. Okay, but you can remember the first one for the exam. There is no cause-effect relation implied in third law. The force on A by B and the force on B by A act at the same instant. So here action and reaction is not like cause-effect relation. Okay, it is not that means the forces A applies on B and B applies on A, they are at the same time. Action and reaction forces act on a different bodies, not on the same bodies, and also it is on the same different body, not on the same body. Okay, acting on the different bodies. That means vector FAB is equal to minus of vector FBA, that is force applied on A by B equal to negative of force applied on B by A. Force on B by A, force on A by B. In a system of two bodies as a whole, now you have got a system which has got two particles. You can have more also, but we consider two particles. Then the force FAB, that is force on A by B, and FBA, that is force on B by A, are internal forces. If you are considering the one system A plus B, then the forces which A applies on B and B applies A will be internal forces. Then they add up to give a null force. Then the internal forces will add up to give you the null force. Common forces in mechanics. Normal reaction. Normal reaction is the force of reaction created by the surface on which the force is applied by another body. So this is always perpendicular force. Okay, so if suppose a body, or let us say a textbook, is resting on a table, then the table will give the force on the body that will be upward. Okay, that you call it as a normal force, that is always towards the perpendicular to the force. Okay, the perpendicular to the contact. We can define this in another way, which I have defined here. When bodies are in contact, there are mutual contact forces satisfying the third law. The component of contact force normal means perpendicular to the surface is called the normal reaction. Okay, the same definition we have written in the contact force. Okay, so this means whenever there are bodies in contact, there is mutual contact forces. Okay, and this force, the component of the contact force normal to the surface is called the normal reaction. That is, normal means perpendicular, and the component parallel, this is perpendicular, this is parallel to the surface in contact, is called friction. This we will learn in the next class. Solid immersed in a fluid, there is an upward buoyant force. Okay, so we know this force, and this is equal to the weight of fluid displaced. Viscous force, air resistance are contact forces. Next we have gravitational force. Now you know this force is existing everywhere on the earth. Okay, every object on earth experiences the force of gravity due to the earth, and also gravity governs the motion of celestial bodies. Tension in a string and force due to spring. When a spring is compressed or extended by an external force, a restoring force is generated. This force is proportional to compression or elongation. The spring force F is given as F is equal to minus kx, where x is displacement and k is force constant. Negative sign indicate that force is opposite to the displacement from the unstretched form. Now this one we have to still study further. Here just we are giving the just like the in a small nutshell we are giving the tension in a string and force due to spring. So first we have taken the force in the spring. So the force in the spring is given by F is equal to minus kx. X is the displacement from the unstretched form. Okay, and this is minus sign because it is the force and the displacement are opposite to each other. This is next we have got the restoring force in a string is called tension. So if you have got a string, that is a restoring force that you call as a tension in a string. The different contact forces, so we have seen these are the contact forces. Okay, the normal force, then the friction force, the buoyant force, the tension in a string, and the force due to spring. These are all called your contact force. Okay, so in the different contact forces of mechanics fundamentally arise from electrical forces. They arise because of the electrical forces. Now we have studied in chapter 1 that there are 4 fundamental forces. One is gravitational, other one is electric force, and other 2 are the strong and weak nuclear forces. Okay, so gravitational force, you know that very well, right? And now electrical forces, we say that the contact forces, most of the mechanical contact forces are arising because of the electrical force. Why? Because as at the microscopic level, all bodies are made of charged constituents. You know that each body is made of electron, proton, neutron, right? So that means at microscopic level, all bodies are made out of the charged particle, right? So that is nuclei and electrons. So these are the common forces in mechanics. It's just a small topic for you to know which are the forces in mechanics. You can see some examples, the figures they have given, examples of contact forces. Okay, these are the forces, they are the contact forces. Okay, you can see it is there in your textbook. Example 5.2. A bullet of mass 0.04 kg moving with a speed of 90 meters per second enters a heavy wooden block and is stopped after a distance of 60 centimeters. What is the average resistive force exerted by the block on the bullet? I have just drawn the small figure here. This is the bullet. Okay, its mass is given to you 0.04 kg and it is moving with the velocity 90 meters per second. And this is the block. It is striking the block and the block moves before it stops. Okay, and when it is the bullet is piercing here in the block, it stops. The velocity becomes 0, the final velocity. And the block will move and it is moving 60 centimeters. Okay, after the bullet is piercing in the block. Okay, so now let us calculate here. Here what is given is initial velocity v naught 90 meter per second. Okay, the beginning velocity. The mass of the bullet m is equal to 0.0 kg. The final velocity v equal to 0 meter per second. Why? Because the bullet stops after piercing into the block, it is stopping. So it is 0 meter per second. The distance traveled, the block is traveling the distance, we will take as a 60 centimeter, convert into meter by multiplying by 10 power minus 2 meter. Now by kinematic equation, we know this equation, it is v square equal to v naught square plus 2ax, right? Now let us put the value v equal to 0. So 0 equal to v0 square plus 2ax. Now if you suppose v naught square transfer over here, it becomes negative, right? So what you get here is 2ax equal to minus of v0 square. Take a as a subject, so a equal to this 2x transfer over here, it will go in the denominator. So a equal to minus v naught square by 2x, right? Now let us place the values. Minus is as it is, v naught given to us 90 meter per second. So 90 into v naught square, so 90 into 90, right? And 2 as it is, and x is the distance travel, that is 60 into 10 power minus 2. Okay, so put the value. Then you can cut this. So you get here 3 and 2. Then here you get minus 90 into 3, and this 10 power minus 2, if you take in the numerator, it becomes plus power, and 2 into 2, 4. If you find this division, you get it as a 6750 meter per second square, that is minus, okay, because it is retardation. The retardation force by second law of motion is F is equal to ma. Okay, the formula I have given you before, F is equal to ma, the second law of motion. So equal to m given to us 0.04 kilogram. So 0.04 into a, acceleration we found just now. Okay, this is the value of a, minus 6750. So minus 6750 multiply, you get 270 Newton. Since it is retardation, you can just omit the negative sign. Retardation means it is decreasing. Okay, so that is the solution for example 5.2. Example 5.3. The motion of a particle of mass n is described by y is equal to ut plus 1 by 2 gt square. Find the force acting on the particle. In this example, they have asked you to find the force, that is, you have to use the second law of motion. Okay, this one, F is equal to ma, you have to use, right? So for that, first thing is that they have given us the motion of the particle in y form, that is displacement form, right? So let us find first, from y we'll find the velocity, from velocity we'll find the acceleration, and mass. With mass will give the fixed mass, and we'll find the force. Okay, so motion of the particle, y is equal to ut plus 1 by 2 gt square. U is the velocity, you can call initial velocity, g is the acceleration, and t is the time, right? So let us differentiate this. To find the velocity, you have to differentiate this with respect to time. So differentiate with respect to t, that is time, right? And you know the derivative, I have taught you in mathematics. Okay, so y will be dy by dt equal to u as it is, and t you have to differentiate with respect to t, that is dt by dt, plus 1 by 2 g as it is, d by dt of t square. Okay, now this is the formula of d by ds of x power n, and the formula is n into x power n minus 1. Okay, this formula you know, n into x power n minus 1, right? So here for the first dt by dt, that is derivative of t with respect to t will become 1. Okay, this also I have given you. So you write here v is equal to u into 1 plus 1 by 2 g as it is, and t square, you use the formula 2. Instead of n, you have got 2 here, right? And it is t with respect to t. So you write here 2 into x power 2 minus 1. So 2 into here, for our calculation it is t. So write here 2 into, that is 2 into t power 2 minus 1. 2 minus 1 is 1. That means 2t you will get, right? So that is the calculation for this one. And here this one is 1. So u into 1 is u, plus this 2 and 2 you can cut, so gt remains here, right? Now this is your v, velocity dy by dt. Now you have to find the acceleration. So once again you have to differentiate this. So again differentiate with respect to time t. So derivative of v dv by dt equal to this one, d by dt of u plus g d by dt, dt by dt. Okay, this t with respect to t. Now u is a constant, that means this derivative is 0, plus g, and t with respect to t is 1. So g into 1 is g, that means dv by dt, and dv by dt is nothing but the acceleration. So a is equal to g. So you have found the value of acceleration. Okay, force is given as y, using this formula, second law of motion, F is equal to ma. So F is equal to ma, a value we found as g, so equal to mg. What is this? This is the motion of a particle under acceleration due to gravity, and y is a position coordinate in direction of g. Example 5.4. A batsman hits back a ball straight in the direction of the bowler without changing its initial speed of 12 meters per second. If the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. Assume linear motion of the ball. Suppose speed of the ball v1 is equal to 12 meter per second, okay, when it comes to hit, okay, and after hitting it is returning back, and it is returning back with the same speed, okay, given in the equation. That means v2 is equal to minus 12 meter per second. Why minus? Because direction is changing, right? So taking as negative. Mass of the ball m equal to 0.15 kg given to us. Now impulse, we have already learned that impulse is equal to force into time duration, but this is nothing but change in the momentum, okay. So we can write impulse equal to change in the momentum. Change in the momentum is, you know the formula of momentum, P is equal to m into v. So mass will not change, right? Only velocity is changing. Should change. Here it is also changing because the direction is changing. So you can write m v1 minus v2, or you can write v2 minus v1. Okay, so m into v1 minus v2. So m is the mass 0.50, v1 12 meter per second minus v2 12, so minus and minus plus 12 equal to 0.50, 12 plus 20, 12 plus 12 is 24, multiply, you get 3.6. It's a impulsive force, it is Newton into second. That means this is in the direction from batsman to bowler. We'll give this much for today. Thank you very much.